Here we are in number 6. Going to read it here. It says, corn tortillas are made at a large facility that produces 100,000 tortillas per day. In each of its 2 production lines, the distribution of diameters of the tortillas produced on the production line A is approximately normal. So there's A, approximately normal, with a mean of 5.9. And the distribution of diameters of tortillas from line B is approximately normal, with a center at about 6.1. The figure below shows the distribution of diameters of the 2 productions. The tortillas produced at the factory are advertised as having a diameter of 6 inches. So this is the advertised price. For the purpose of quality control, a sample of 200 tortillas is selected and the diameters are measured. So I'm going to do a sample size 200. Just writing notes to myself. I don't know what any of the questions are yet. From the sample of 200 tortillas, the manager of the facility wants to estimate the mean diameter. Which usually means we're going to make a confidence interval. Wants to estimate the mean diameter in inches of the 200,000 tortillas produced on any given day. And here are 2 different sampling techniques. Sampling technique A is we take a random sample of 200 tortillas from the 200,000. And measure the diameter of each tortilla. Method 2, randomly select one of the 2 production lines on a given day. So on a given day, we'll randomly select A. Take a random sample of 200 tortillas from the 100,000 produced by that selected production line, because each one does 100,000. And then measure the diameter of each tortilla. So method 1 is a random selection of the 200 from all tortillas, and 2 is you randomly select a production line, then you randomly select 200 tortillas from that production line. It says, will a sample obtained using method 2 be representative of the population of all tortillas made that day? And the answer is no, it will not. So I'll start with just answer the question. Will it be a representative sample? No. Since we are only sampling from one distribution, and the 2 distributions are different, right? Because they have a different mean for each. So no, since we're only sampling from one distribution, the 2 distributions are different. This method will only be representative of either A or B, but not both. For tortilla diameters. I throw that in at the end because you never know. Maybe that might be what I need to do to have context. Like, oh, did they say context in there? All right. So a sample obtained using method 2 is not representative of all tortillas. The sample obtained using 2 will only represent the tortillas from one production line, not from the entire population, because the distributions of diameters are different. All right? B. The figure below is a histogram of the 200. All right, so this is a histogram, number of tortillas. So this is the histogram of all the diameters of the 200. So if I would count frequency of all of those and add them up, I would get 200 because there were 200 diameters. Considering the shape of this histogram, which, by the way, looks to me like it's kind of bimodal, is this likely bimodal, AL, it says, considering the shape, explain which method 1 or method 2 was most likely used to obtain such a sample. All right. So it's going to be 1 or 2, and the answer is it's method 1. Because it samples from both distributions, which means I would expect to have higher frequencies near the means of each distribution. And those means, again, were at 5.9 inches and 6.1 inches. And that's what I see. All right, so method 1 is most likely used. The bimodal shape of the histogram indicates that the tortillas are selected from both production lines. All right. If it was from only one distribution, I would expect this distribution, or this sample distribution, because it's the distribution of the sample, to be unimodal. You'd expect there would only be one peak if it was only from one of them. It would probably follow a normal curve since it came from a normal curve. All right, but this is the information that would be necessary to answer part B. Moving on to C. C, which of the two sampling methods, 1 or 2, will result in less variability in the diameters of the sample distributions? All right, so is it going to be method 1 or method 2? So method 1 is, reminder again, we are going to take a random sample of 200 from both distributions, and method 2 is we randomly select from one of the two production lines. All right. So which one will give me a less variability? And the answer is method 2. Method 2 results in less variability because the sample comes from one production line only. All right. And because since the distributions of the diameters are not the same, selecting from both would result in more more variable sample data. Okay. All right. So, and again, if you look at what we did in letter B, you could even go in there and say, that sample distribution ranged from 5.7 up to 6.2. In either of the two distributions of the original data, the first one would go from maybe 5.8 to 6, and the second one, production line B, would go from maybe 6 to 6.2, because that's where most of the data falls and lies within each one. But by doing both of them, I'm getting all the way down from 5.8, 5.77, all the way up to 6.2, which would be impossible to get if you were just in one of them. Which is why method 2 results in less variability. So now I have each distribution of 200 tortillas made that day has mean diameter 6 and standard deviation of 0.11. So they're telling us that of all the 200,000 tortillas that we make in a day, the mean is 6 and the standard deviation is 0.11. All right, so based on that information, what we know about the whole population, it says for samples of size 200 taken from 1 day's production, so this particular day when the mean is 6 and the standard deviation is 0.11, it says describe the sampling distribution of the sample mean diameter for samples obtained using method 1. All right, so again, it says describe the distribution. So automatically you're thinking to yourself, shape, center, spread, outliers. All right, so what will that distribution look like if I'm using method 1? All right, method 1, believe it or not, we've already looked at, didn't we? All right, that was what letter B was. So it would likely be check that. Describe the, I almost messed up on that one because I got to look back and I got to read the question. It says describe the sampling distribution. So this, what we did in letter B, was the sample distribution. So now they're saying the sampling distribution. All right, sampling distribution, I have 200 in my N, which means that since N is over 30, since N is at least 30, the sampling distribution is approximately normal. That, my friends, is the central limit theorem. And the mean of X bar, let me change the color on that. The mean of X bar will equal the mean, which is 6 inches. Okay? And the, I'll zoom in here so I can just write easier. The standard deviation of X bar will equal sigma over root n, which is 0.11, because that information was given to me, divided by the square root of 200, which is approximately 0.0078 inches. Shape, center, spread. Boom, done. I didn't have to even use words when I did that. I identified the shape, the center, and the spread. But the key was I had to recognize that it's talking about a sampling distribution. All right, that's letter D. Moving on here. Letter E. It's a big problem here, folks, because this is number 6 and it seems to take a long time. Letter E says, suppose that one of the 2 sampling methods will be selected and used every day for 1 year. The sample mean of the 200 diameters will be recorded each day. That is, there will be 365 averages plotted. All right, and each of them will come from a sample of size 200. Which of the 2 methods will result in less variability in the distribution of the 365 sample means? And explain my answer. All right, so part of what is going to be the challenge in this question is recognizing what they mean when they say that each day. All right, I kind of missed it there. One interpretation that ends up being the wrong interpretation is that suppose they, if you read the question and read it as, suppose that one of the 2 sampling methods will be selected and used every day, that what they're saying is that they're going to choose one method and use that one method for every day. But what they're actually saying grammatically is, suppose that one of the two sampling methods will be selected and used each day. Now, they didn't say the word each, but that's the idea. So one day they're going to do method 1, and then one day they're going to use method 2, and they're going to go back and forth all year long. So they're going to randomly select so many days to get A, or method 1, and so many days to be method 2, and they're going to do that for 365 days. Which of the two methods will result in less variability? And the answer is, I'm going to do it down here at the bottom, give myself a little bit more space, is method 1. All right, and here's the reason why, and listen carefully for why it's method 1, because there's a lot of people that are going to want to say, it's got to be method 2. Method 1 will likely result in averages, x bar values that are close to 6. All right, and there'll be some a little bit less and some a little bit more because the standard deviation is 0.11. But when we're doing this, that I'm expecting that roughly, you could say roughly half of the sample means. Sorry, just coughing here, folks. Are close to 6. Using method 2, about half will be near, about half of the x bars, that is. About half the x bars will be near 5.9, and the others will be near 6.1, and resulting in a higher variability than method 1. Okay, trust me, that word there is method. That's really about all you have to say in a problem like this. The hardest part in answering letter E is figuring out what's the question really asking. So again, what they're talking about is, suppose that one of the two methods is selected and used, and we do this whole thing for a whole year, which is going to result in less variability. Using the one sample, so remember in letter B we did the graph and it's bimodal and it's really spread out. But the average of that sample is probably going to be close to 6 because it represents all the possible tortillas. And we know from what we're told in this question is that the average of all the samples will be 6. All right, so there will be some variability, yes. However, it'll be pretty close to that 6 value. And what I did in letter D is I said that the standard deviation will be 0.0078. which is really close to 6. Way less than the 5.9 and the 6.1, which we see from the averages of the two individual samples if we had done method 2. All right, so the center for method 1 will be 5.9, will be 6, and it'll only differ on average about 0.0078 for every single sample that I do, which is much closer than being from 5.9 and 6.1. So you're going to end up with having greater variability using method 2 and lesser variability using method 1. Now I didn't write all of that down, but you could definitely write more. I kind of ran out of room. But that's what I would go back and say as well, is because the mean of x bar for method 1 is 6, sigma sub x bar is 0.0078, I'm going to have a distribution much closer to 6 than I would had I used method 2, because it fluctuates again. Method 2 down to 5.9 for about half of them, up to 6.1 for about half of them, which is a much wider range than what I have using this number right there. Okay, I'm going to kind of shrink that up and throw that out of the way and go on to letter F, the last part of this problem. It says a government inspector will visit the facility on this particular day to observe the sampling and to determine if the factory is compliant with the advertised mean diameter of 6. The manager knows that that both sampling methods, the manager knows that with both sampling methods, the sample mean is an unbiased estimate of the population mean. However, the manager is unsure which method is more likely to produce a sample mean that is close to 6 inches on the day of sampling. Based on your previous answer, so this is where, depending on what you did in letter E, you could still get some partial credit. Based on your previous answer, which of the two methods, 1 or 2, is more likely to produce a sample mean close to 6 inches? And again, the answer is method 1 is much more likely to produce a sample mean that's close to 6 inches. This is because the sample mean is an unbiased estimator. The manager should pick the method that would result in less variability. All right, because that's, again, you're going to be more likely close to the actual center if you pick the one with less variability, which we said in letter E is method 1. Method 1, since it will have less variability and therefore be more likely to have a sample average X bar near 6 inches. All right. Again, method 1 has less variability, and if both of them are unbiased estimators, that means they both would give an average of 6 inches, but since method 1 has less variability, there's a greater chance that I'll have one that's really close to 6 than method 2, because it'll be some above and some below over the whole year, that is. So the manager should pick this method, and the reason why is it results in there's less variability, so there's a greater chance that it will be actually close to 6. That's a lot of answers to what we did for this whole problem. I'm not going to go through the scoring for this particular problem because that was just a lot of work for me to do in getting it all written out. But this was a question 6, and it's meant to be a longer question. It's meant to take you 25 to 30 minutes and ask you questions that are going to challenge you to think a little bit deeper or maybe a little bit different than you have in the past about a particular problem. The hard part, I know, in 2015 when kids took this exam is they came away saying, number 6 wasn't actually that challenging, or they didn't think it was that challenging. And the problem was they didn't understand what the questions were asking, and that's why they thought it was less challenging. All right, so that's it for number 6. I'll see you in class or sometime soon.